about the work in our lab around trying to understand the spread of information and misinformation in social media. So I always like to start with this pretty movie to just illustrate the beauty of information diffusion. This happens to be the spread of one viral meme on Facebook about Marvin the Martian, which was done at the time of the lander. So it was funny, so it spread virally. And the picture shows how that is going from person to person, and we see these beautiful images that represent the role of the clusters and the communities. It also shows these bursts that characterize the diffusion. And we observe these kinds of features in the spread of information in general. And so we look at the relationship between the structure of the network and the dynamics and the virality of information. But not all the information that spreads virally is funny or even true. So this is an example of fake news that was spread just around the last presidential elections, claiming that one of the candidates was involved in satanic rituals. And as crazy as it might seem, it spread virally. Here's a picture of the network of people on Twitter who reshared and retweeted. In particular, this is the retweet network. A link to this particular piece of fake news. This picture is nice. Actually, it doesn't even show the entire network because I couldn't really fit it on a slide. It shows the most dense core of the network. And we see that some nodes are larger. Those are very influential accounts that are retweeted hundreds or even thousands of times. And we also see that the nodes have colors. So for example, the yellow ones are ones that are not active anymore. And this is what happens sometimes, especially people who set up accounts to amplify fake news. Sometimes then they take them down or delete all their tweets so that they can't be traced or evaluated. And for the other ones, the color, blue means that it's probably a human, red means that it's probably a bot. And I will tell you later about how we try to assess whether an account is controlled by a human or by software. So we see that there are some nodes, especially, let's see if I can have a pointer. Can you see the pointer here? So you see some examples here. These are nodes that are maybe not quite as popular as these, which are, of course, the websites themselves, Alex Jones and so on, that InfoWars that's spreading those particular links. But here are other accounts that claim to be regular users and have a lot of followers and have a lot of retweets. And they have a high likelihood of being bots. So this tells us something. I'll tell you more about this, but this is one way in which the viral spread can be somewhat controlled, ignited. So here's some examples of fake news. Many of these are completely familiar to you. You've seen them many times. And it's kind of unbelievable that they are still going around. Things like Obama is a Muslim and vaccines cause autism. Very dangerous. People don't vaccinate their children, and we have outbreaks. Sandy Hook was fake news. Imagine being a parent to a victim and still seeing that stuff going around. The next one, 3 million votes in presidential election cast by illegal aliens. Of course, we've all heard that. That's one that actually also spread very, very virally. And hundreds of people mentioned Donald Trump in the context of sharing this particular.
Is that how he got elected?
So you can see in this example here, this is a typical example. And we do see that many people who tweet or retweet links to fake news, they mention influential people, whether they are politicians or whether they are journalists. And this is another way in which they can sort of manipulate things because they induce people to pay attention to these fake news, and then sometimes journalists or even talk about them, and sometimes even politicians. 3 days after this, of course, the president talked about this as if it was a fact. The next one is, we are familiar with it, the Comet Pizza conspiracy theory. And the last one, some of you may have heard, others have not. This is the claim that Obama spent $1 million for a project to suspend conservative Twitter accounts. So for those who have not heard about it, let me tell you just a little bit to set the stage. a colleague of mine, Johan Bolland, called me in the morning. I was on sabbatical in California. He said, turn on the TV, and this is what I saw. So I'll just
Tonight,
play
first on the Kelly File, new
minutes.
reports that the federal government is spending close to $1 million of your money on an online tracking program that will search for so-called hate speech or misinformation on Twitter. So some bureaucrat decides whether you are being hateful or misinforming people. What could possibly go wrong? Chris Steyerwalt is our Fox News digital politics editor. The Senate just failed to pass a bill that would do something similar to this. And while they were saying, look over here, we denied that, we're not going to pass that, another federal agency was saying, we just got $1 million to do it over here, don't worry.
Well, and do it through a partnership, do it through academia. So we're just looking, and they call
not
it.
to worry.
Not to worry, it's fine. You can trust academia to get it right, and they'll be monitoring Twitter, and they've got a logarithm that they can go through, and they can monitor your Facebook.
Okay.
They can.
I wanted to get to the logarithm because at least there is some humor in it, but believe me, it was not funny. I could talk about this for hours and bore you to death, so I will try not to do this, but there are so many pieces of it. The federal agency that is secretly doing this was actually an NSF grant. But because the NSF is a federal agency, this became a federal project. And the way that the original fake news about this was built is that this was a federal project of the Obama administration to more or less secretly spy on citizens and specifically target conservatives. Of course, that was completely made up. The whole claim was based on one sentence that was completely taken out of context from the NSF abstracts about future broader impact, which talked about the fact that if we build systems that help us understand how information spreads on social media and how that spread could be manipulated, for example, through social bots, then we could sort of prevent this kind of abuse, and the web could be, and social media could be preserved as a way to, have conversations among people. But this was billed as an attack on free speech, and it spread virally because of Fox News that had several pieces about it. And it was debunked almost immediately by several sources, including Science, Columbia Journalism Report, and also all the major computing organizations wrote letters about it. In spite of that, it kept going. It was pushed by Ajit Pai. Many of you know who he is, who at the time was a commissioner and published an op-ed in the Washington Post, assuming the original claim as if it were true and making the point that the federal government should not support research that basically attacks free speech. So sort of assuming that the original claim was true and then making an interesting argument. And then that spread virally again. Eventually it reached Congress. There was an announcement about a formal investigation by the chairman of the House Science Committee, even after this had been debunked and after he had received letters from the aforementioned computing organizations. And then the elections happened. This was the midterm elections of 2014, and then it all went quiet. So it is kind of scary, but it is one example, and it can happen to any one of us. And I will show you one of the many different threads that this meme took. Of course, it mutated over time. One particular mutation was actually published by National Report, which is a well-known fake news website. These days, it tends to be more satirical, but a few years ago, it wasn't satirical at all. And the particular mutation here is that there was an interview with a non-existing FBI agent that said that, in fact, the FBI was building a secret database of Americans sharing memes, political memes, on social media. Imagine an FBI agent who gives an interview about a secret database. So this was done a few days after the original claim came out, and then nothing happened. And then years later, In March 2016, it was picked up by InfoWars and other conspiracy theory websites. And we can trace this one because they all refer to the non-existing FBI agent by name, and they actually give the source. So we know that they took it from National Report. So they picked up fake news websites, shared it. Then from there, it went to a bunch of political blogs and political websites. From there, it was picked up by a Russian blog. And from there, it was picked up by Sputnik, Russia Today, in many of their international editions. So it spread quite virally in South America, in Korea, and so on. So I'm just showing a few examples. Here, for example, is the Korean version that says it had a balloon from $1 million to $100 million. Here it says that the federal government has spent $100 million. So I must have all this money hidden somewhere. Talk to me later if you want a grant. So needless to say, on social media, there was a nice interaction between the spreading in sort of traditional media and the spread online. The story mutated over time. That reflected the different versions that appeared online. The suspension of conservative accounts, which of course was also non-existent, and so on and so forth. All right, so that's one example to say that it is relatively easy for any piece of misinformation to pick up and spread. So I want to say a little bit about our research that tries to study and understand how misinformation spreads. And then later, I'll say a little bit about projects where we're trying to understand what makes us vulnerable. So first half is on the production, the second half is on the consumption. So we started studying this several years ago, from around 2010. The work was actually inspired in part by the work of Takis Metaxas, who's sitting over there. He and his group had shown that it was possible with fake accounts to create messages about the elections and make them go viral. So we started looking systematically at whether we could find this kind of astroturf or fake grassroots campaigns. And we we tried to look at the patterns of spread by considering the diffusion networks. So these are examples of diffusion networks. A diffusion network is a network where a node is a user, and the connection between two users represents that a piece of information is spreading from one person to the other, for example, through a retweet, or through a mention, or a quote, or a reply, and so on. And in these pictures, blue represents a retweet, and a blue edge represents a retweet, and an orange edge represents a mention. So at the top, we have examples of grassroots campaign. These were mostly regular people talking about politics and other things. And at the bottom, we see some kind of different patterns that caught our attention. So we looked at them a little bit more carefully, and we found that, in fact, these were kind of manipulations. So let me mention a couple. These two are two accounts that were retweeting each other, supporting a particular candidate. They were tweeting links to this candidate, to this person's platform, website, official site, articles about this person, etc. And they were retweeting each other tens of thousands of times. But somehow they were not kind of triggering sort of detection mechanisms by the platform. So they were successful in making the particular meme that they were promoting, which was the name of this politician, to go trending. And in fact, this politician got elected with an avalanche and became very powerful with a lot of votes and so on. So in fact, these are the same two accounts where you can see that one is particularly mentioning this candidate. So in this case, the meme is the Twitter username of this person. So of course, these two were bots. No human could produce, that many tweets at that high rate. And but they were successful in sort of triggering the trending mechanism on Twitter. Here's another interesting example. These are a bunch of bots that are all controlled by one account, and they would share links to a fake news website. This is one of the first fake news websites that we found. It was not maybe quite as sophisticated as the ones we have now, but it was still pretty real looking. And of course, all the articles were completely fabricated. They were all either supporting some candidates or attacking, smearing other candidates. And then what this person would do, it was the same person who owned the fake news website. He also controlled these different Twitter accounts. And he would tweet links to these articles mentioning an influential person. That's the person in the middle here. This person was actually a reporter. So they were trying to get the attention of an influential person, as I mentioned earlier. And they were able to elude Twitter's controls by adding some random characters at the end of the URL. It was a bit.ly URL. You could add random characters at the end so that the platform would not notice the bot-like or spam-like behavior. And they were effective. Sometimes journalists would then retweet this thinking, well, a lot of people are talking about this. There might be something behind it. Let me look at it. So we built a machine learning framework that used a large number of features characterizing the structure of these networks to try and see if we could automatically separate the grassroots from the AstroTurf. And at that time, that algorithm worked pretty well. It was quite accurate, but we also have to consider that most of the kind of AstroTurf campaigns that we detected were pretty simple. So later, we started focusing not so much on the message itself, whether it is promoted by artificial means, but on the messengers, on the accounts. And we started to try to understand better social bots and how they work. And this work now, of course, has become very popular. We all hear about social bots, but this was kind of early on. This was the cover of Computing magazine about it. And of course, not all social bots are bad, right? So many social bots are perfectly benign. We like them. For example, news sources have accounts that automatically post links to their articles, and there's nothing wrong with that. You know what it is. But there are also bots that are deceptive because they make it look like they're regular users. They impersonate others. They use fake pictures, fake names. And then they use that to manipulate somehow the information ecosystem. So there are lots of different kinds of bots. This is one that was meant to be completely benign, but it turns out that it could also be manipulated. I'm sure many of you have heard about it. But fake accounts are used to make it look like people have more followers so that they receive more attention. To automatically retweet content, to manipulate the stock market. This has happened multiple times because, of course, also investment companies use bots that listen. And when there's chatter about something, they can be tricked. And so some bots exploited that, and they were able to take a company that was worthless, had gone bankrupt, and make it valued at billions and make a boatload of money that way. Bots don't have to be very sophisticated to trick people. So here, in the case of Ashley Madison, all they had to do is just send a message and ask for a credit card number, and that worked. We have bots that have been used to suppress organized protests. We've seen this in Iran, in Russia, and in Mexico, among other places, where you can just use bots to simply flood the space of a hashtag that is used by real people to communicate. And by doing that, you're basically completely disrupting that communication because people can no longer find the information that they seek. They can no longer communicate with each other because the real messages are flooded in a sea of junk. And then, of course, there's all the claims that Twitter bots played a role in the elections, and we don't know whether that is true or not. I think I get this question all the time, and my answer is there's no way of knowing whether that is true or not. I don't think that we can rule it out, and I also don't think that you can prove it. Certainly, we know that there have been attempts to do that, and I'll say more about that, but who knows? But the fact that we don't know is itself something, in my opinion, to worry about. So we built a system, again, a machine learning tool, trying to see if we could recognize whether an account is a bot or a human. It used not only the network features, as I mentioned before, but a lot of other features about metadata, about temporal patterns, for example, whether an account is tweeting at regular intervals or at very high frequency. whether the account is recent or not, and then look at the structure of the follower network and the mention network and the retweet networks, look at the characteristics of their friends, and also something about the content. For example, different usage of different parts of speech, and sentiment analysis and so on. So it was kind of a kitchen sink approach. We threw all of these features and to see if the classifier could work. And for using the training data that we had available to us, this worked quite well. So, for example, we were able to detect relatively simple bots, which were available to us through the research of a colleague, Jim Caverly, at Texas AMU. And these were mostly sort of spam bots, so we could recognize them because they tended to retweet more than tweet. They were created recently. They tended to, for example, have long usernames, etc. The question is whether this kind of system is as useful to detect more sophisticated bots. But we used some of the lessons that we had learned when we participated in a challenge organized by DARPA that was meant to detect some bots that were trying to affect discussions about vaccines. And it worked quite well. We were able to detect all of the bots there. And in so doing, we learned about some of the more sophisticated strategies that bots can use. For example, they can use fake images from Wikipedia. They can have descriptions that look very real. But then there are usually some other features that give them away. For example, big bursts of activity that does not seem human-like, or simple and repetitive content, things of that sort. So we wanted to improve the classifier to be able to detect these more sophisticated bots, because of course, not all bots are the same. This is very much not a binary problem. There's all sorts of stuff under the sun. There are people who are obviously humans and accounts that are typically bots, but there's a lot of stuff in between. There are humans who tweet like bots using software, for example, that tweets their stuff regularly or that automatically retweets things from certain websites and so on. And then there are, of course, bots that look very, very human. So we have false positives, we have false negatives. For example, our system tends to misclassify organizational accounts like POTUS, for example, which is not managed by a person, but is managed by a team. And so the patterns that we observe there sometimes is that those things look a little bit like bots. So that's something interesting to look at, whether we can distinguish organizational accounts from single user account. But by using different mixes of more sophisticated bots and simpler bots, we were able to sort of calibrate our model and come up with an estimate, for example, of the prevalence of bots. How many accounts out there might be bots? So depending on how you train it with different mixtures of training examples, you get more conservative or more aggressive estimates. And so I'll spare the technical details, but we ended up with estimates that ranged between 9 and 15%. This is between 9 and 15% of Twitter accounts that might be controlled, at least in part, through software. Our system is available. You're welcome to play with it. It's called Botometer. And you can just Google Botometer. You can find it. There's a nice web interface. You can enter an account, or you can just check all the followers of an account, for example. And there are nice features like, if you really think this is a bot, you can, for example, unfollow it. And that's really useful to us because we can collect this feedback and then use these to improve our training. And you can also access this data programmatically. There is a free API, and you can use it if you want to incorporate Botometer into other products. And it's used quite heavily. We've served tens of millions of queries since we launched, and not long ago. So we're kind of excited, and we're trying to always make it better. So Botometer is one of a set of tools that we're making available through a project called Observatory on Social Media, or AWESOME in short, because it is awesome. And you can go there, and you can find lots of different tools. I will tell you a little bit more about a couple of other ones in addition to Botometer. But there are tools to create visualizations of hashtag co-occurrence networks and retweet networks, looking at trends, looking at geographic patterns over time. So you can use it sort of to study the diffusion of information on Twitter. So here's an example. This is an interactive network visualization of a hashtag. So here you can enter a hashtag, like here, in this example, it's Ice Bucket Challenge, if I can find my mouse. And you can enter a period of time, and then this will show you how that particular hashtag spread from person to person. This is based on a sample of about 10% of public tweets. And so in this case, you can see that this particular hashtag, which was going viral during that time, went from cluster to cluster, and generally these clusters were based on some celebrities that would try to promote the cause by, running the Ice Bucket Challenge and then challenging their friends. So you can see some of these celebrities, Katy Perry here, Jimmy Fallon here, and so on and so forth. So one thing that is interesting is to combine these diffusion networks, where you see how a piece of information or misinformation is spreading from person to person, with information about bots, so that you can try to study who is spreading this stuff. Is there manipulation going on? So for example, you can use the Awesome API to build a network of propagation of a hashtag. Let's say, for example, SB277. SB277 is a hashtag that talks about a proposed law in California to make it harder for parents to be excused from vaccinating their children for various reasons. So there was a lot of debate around this law because, of course, you had people who were arguing that people are not vaccinating their children and this is dangerous and it's leading to outbreaks. There were also concerned parents who were worried that vaccines might be harmful for their children, and so were arguing that the government should not force them to vaccinate their children. So it was a lively debate, and we wanted to see how people were talking about it and who was talking about it. So what you can do is you can basically feed this network into the Botometer API and see whether some of the accounts that are involved in this conversation might be bots. So here's a visualization that we did about this particular SB277 retweet network. The size of the node is proportional to the influence, how many times they are retweeted. And the color is proportional to the bot score. So red means more likely a bot. So the interesting thing that we noticed when we did this for the first time is that there are some accounts that are very influential and that might be bots. So this suggests that you can actually have a big influence on the conversation by creating fake accounts that automatically reshare, in this case, misinformation about non-existing harms of vaccines. We did the same kind of analysis in other cases. Here, for example, is Brexit. There had been some claims that bots were used to affect the online discussion about Brexit. And we also found some of the most influential accounts here that were also most likely bots. These are the big red dots. And so then we tried to do this a little bit more systematically. We wanted to build a tool that would allow anyone to look at not just how hashtags or other memes spread, but links to news. Because, of course, we're all interested in fake news and misinformation, and our goal there was to specifically try and understand how this particular type of information, misinformation, fake news, conspiracy theories, spread, and how they compete with fact-checking information. Because a lot of our efforts are spent into fact-checking, but it's kind of hard to quantify the effect of that fact checks. How does a piece of debunked information and the debunking information, how do they compete with each other for the limited attention of the people? So we built a system called Hoaxy. This is available. You can Google it and play with it. And we are tracking a set of websites that are known to routinely publish information that is debunked, as well as some fact-checking websites. And it works like a search engine. You submit a query, and you get a bunch of articles that are in the search engines that match your query. And then you can select one or more of them and then you visualize the spread of those links to those particular articles. So you get an image like this. On the left, you can see over time how many people are sharing this on Twitter. The top line here is the number of people who are sharing the fake news in this particular case, and this line here is about people sharing the fact-checking. So that's the first depressing observation. But when you look at the network, you gain a lot more insight. Okay, so for example, the first thing that you notice, the gray edges here are people who are spreading the fake news, and the orange edges here are the people who are sharing the debunking. So the first thing that you notice is that the people, even if the debunking is widely shared, it is shared by a completely different set of users. So the ones who have seen the fake news and believe it and shared it, they never even see the debunking. Or if they see it, they don't share it. So this cluster at the top, which some people would call it sort of an echo chamber, is kind of impermeable to sort of penetration by these corrections. You can also see the role of some important accounts, of course. You can see that some important accounts are probably bots. Here, this is a version of Hoaxy, by the way, that is not out yet. This is a prototype. The current version, we don't label nodes with the bot score, but with some generous support from Democracy Fund and the Knight Prototype Fund, we are trying to incorporate this additional feature. Mihai is one of our graduate students. He's sitting over there. He's one of the people who is developing this new improved system. And so what we want to do is we want to allow people not only to show how stuff spreads, but also who's spreading it and whether there is artificial manipulation through bots. And you also see that some influential accounts are often mentioned in the context of this fake news. And this is what I mentioned before. This is one way to get the stuff to go viral. Put it in front of people who have the power to amplify it. Okay, so we did a little bit of a more systematic analysis of the data that we've been collecting from Hoaxy. We looked at about 400,000 claims. These are claims from websites that are most likely misinformation. We didn't check each one, but they're all from websites that have been labeled by fact checkers and news organizations as fake news websites. And there were about 14 million tweets sharing these fake news articles. And the first thing that we observe is that the fact checks and the misinformation have basically the same statistical profile when it comes to virality. So without going into the details, these two plots show you that the likelihood of a piece of information going viral, as represented by the number of users who share it or the number of tweets in which the article is shared, is basically indistinguishable between fake news and debunks. Both of them have the same likelihood of going viral. And this is the same exact result that we have found in analysis of Facebook data based on labels that were provided by Craig Silverman's group at the Emergent.info project. So, for example, the example that I showed you before, the one about the Clinton campaign organized in being involved in satanic rituals, that one, of course, would have been one in the tail of this distribution. It has more than 30,000 shares. So the tails here represent the stuff that goes really viral. It is rare, but not that rare. So we looked at who's spreading this stuff. And we noticed that, for example, when you look at the number of times that an account shares the same link to the same article, interestingly, we get this kind of curves. What this tells us is that there are some accounts who share the same news thousands of times. Okay? So, in fact, when we looked at all the claims and we organized them by how viral they are, and then we looked at whether these were shared sort of widely by lots of different people or by a small subset that kind of dominated that spread. And we found that the most viral the claims are, the greater role was played by a relatively small subset of accounts that accounted for a significant fraction of the spread. this is measured by the Gini coefficient, which is a coefficient of inequality. Basically, it sort of quantifies whether a small number of accounts is responsible for a large fraction of the sharing. And so it turns out that when some accounts are able to really push this stuff out, they can sort of somehow trigger a cascade. So then we looked at the distribution of bot scores for these super spreaders, the 1,000 accounts that most actively share fake news, versus a random sample of the accounts who share fake news, still sharing fake news, but just the regular ones versus the ones that are doing this over and over again. And you can see that the two distributions are statistically very different. This is typical of what we observe about bot-o-meter score. We're not 100% sure, but when you look at the distribution, you can find a strong statistical signal. So what this says is that bots are the super spreaders, and sort of first finding. The second one, we looked at how they do this, and we looked over time. When are they most active? And it turns out, this plot here shows you that bots are particularly active very early on, in the first few seconds after an article is posted. So that suggests that these bots are coordinating with the websites, maybe they're the same people, who are posting the fake news. And immediately after the fake news is posted, they share it a lot. This is what Facebook refers to as amplification, fake amplification, right? So that way they can put it in front of the eyeballs of many people. And then after that, once something becomes viral, then regular people start sharing it, and then you don't really see the effect of those bots. But early on, you really see it. And another strategy that you see, I've mentioned it before, is that of targeting influential people. So this network here is trying to focus. This is for one particular fake news, the one about the 3 million votes by illegal aliens. And it shows in blue the retweets and in red mentions. This is a very small subset of that network, by the way. And the size of the node here represents how many followers an account has. And so what I'm trying to show you here, that in this particular news, there were a lot of mentions of this particular user, who, of course, is extremely influential. And then we looked at that, and it turns out that many of those mentions were coming from a small set of accounts that have a very high bot score. So this suggests that this is another strategy that bots can use. They can mention influential accounts, hoping that they think that this stuff is coming from multiple people and might trigger a cascade. Are they effective? Okay, so we looked at retweets. Who's retweeting whom? Again, in the context of links to fake news. So what we see here on the left is that basically let me focus on the top one. So basically, this is a density plot that looks at the bot score of the person who does the retweeting versus the bot score of the account that is retweeted. Okay, so when we project it along the dimensions of the bot score of the retweeter, we see that most of the retweeting is done by humans. Okay? Then if we look at what the humans retweet or who they retweet, by taking just this part of the density plot, those are the things that are retweeted by accounts that are more likely to be humans, and you see that they retweet accounts that are humans as well as accounts that are bots. So this says that humans do most of the retweeting, but they tweet bots as much as humans. So this suggests that bots are in fact effective, and this is consistent with results by our colleague Emilio Ferrara, who has looked at bots tweeting about the elections prior to the last elections, and found that humans are retweeting a lot of the content posted by bots. All right, so I don't know how I'm doing with time, but okay, great, because I'm going to switch to the second part. I want to tell you a little bit about our work on factors that make us vulnerable in terms of consuming the information. So this picture here shows a typical pattern that we observe in social media when we look at the distribution of popularity of things, which could be people or memes or etc. So we observe this kind of statistical distribution of popularity It's a broad distribution. It shows that most things don't go viral, or most people are not viral, but a few are very, very, very viral. So this is something standard that we are familiar with, we understand. But we don't necessarily understand how exactly that happens. So we built some agent-based models, very simplified, almost toy-like models, where we try to assume that we have a system kind of like Facebook or Twitter, where people do very simple things. They have a screen, they share things with their friends, they may reshare things that they see from their friends. They are organized into a network that has the same kind of structural features that we know about social networks. And then we incorporate certain assumptions in these models to see if these assumptions help us explain some of the patterns that we observe at sort of on a large scale. So one of the things that this kind of model has helped us understand is that we can reproduce these broad distributions of popularity that I showed you earlier, basically the empirical patterns of popularity, by assuming very little. We can simply assume that networks are that people are connected in a network that has the structure of a social network, and we understand what that is, high clustering coefficient, the existence of hubs, and so on. And a second ingredient that is necessary is that people have finite attention. In other words, that they don't see everything that is posted. They only see a small fraction of it, and after a while they forget. But while things are on their mind, they may reshare it. Okay? And so we can tune in this simple toy model how much attention they have, how far back in time they can look, how much of their feed they can actually look at before they decide to share something. And so if we cook into this simple model the fact that agents have finite attention, basically what you get is these kind of patterns where some things go extremely viral and most things don't. And these patterns match the empirical ones. So we're able to reproduce the patterns of virality without assuming that some things are more interesting than others. In this model, there's no notion of quality or accuracy or interestingness or anything like that, right? Each meme is just a silly number in the computer. And yet, some of them go very viral. So it's kind of inevitable that some stuff will go viral, irrespective of its quality. Now, in this model, like I said, there's no notion of quality. What if you add the notion of quality? What if you add another ingredient in the model where you say, okay, there is some quality, a number associated with the things that people are spreading. And furthermore, people can look at that number. They can tell whether something is good quality or not. And they will preferentially share the good quality stuff over the low quality stuff. All right, so this is good. Now we're going to have the good stuff that goes viral, right? Wrong. It turns out that, yes, there is some correlation between quality and virality, but it's a weak correlation. Now, what you find in this model depends on some additional assumptions, okay? So two very important assumptions are, first one, as I mentioned before, is how much attention you have, how much stuff you can pay attention to. In this plot here, that's what the vertical dimension represents, how many things people look at before they decide what to share. And the other point is how much information is produced overall. Because if more stuff is produced, even if my attention is the same, the stuff that I can pay attention to is going to be a smaller fraction of all the stuff that is out there. Okay? So that's the x-axis here. We call it information load, right? So if there is a lot of stuff that everybody produces, then people are overloaded, and they can't possibly pay attention to everything. And what we observe is that, well, in an ideal situation where information load is low and or attention is unbounded, then, yeah, the good stuff wins. But if the attention is not very high or the information load is high, the correlation, the color here represents the correlation between virality and quality. That correlation becomes quite small. Okay? So you might ask, oh, by the way, these pictures at the top sort of illustrate these kind of situations. So when information load is low or attention is high, mostly the good stuff, which here is represented by the size of the nodes, is what people are sharing. Although there's not a lot of diversity in this system. But the best stuff is the one that is shared. On the other opposite side of the spectrum, you have a situation where people cannot pay attention to everything, and a lot of the stuff that gets shared is very low quality, as you can see by the small size of the nodes here. On the other hand, there's a lot of diversity, but most of that stuff is junk. Wouldn't it be nice to have an ideal situation in between where you still have some diversity, but where the good stuff, is more likely to go viral? Well, the model tells us that that is possible. There are combinations of parameters in which you would have that ideal situation. However, how do we calibrate these parameters? Like in the real world, what number do we put in our model for these quantities? Well, it turns out that we can get some empirical data to do this calibration. So for example, we can look at data from Twitter to see how many new links people share versus how many links they reshare from other people. And that gives us a quantification for the sort of distribution of this quantity, which is the generation of new stuff versus just resharing of stuff that is already in the system. And that's what this plot here shows. And we also can get a rough idea about the patterns of attention by looking at, when you scroll on a social media feed, how many things do you look at? And I was fortunate to work at Yahoo during my sabbatical and to be able to look at this kind of data about the distribution of the number of things that you look at when you're scrolling through a social media feed. And the bottom plot shows you that distribution. So without going into more technical details, we were able to then incorporate these distributions into the model, okay? So that we have some hope of reproducing the empirical patterns of information load and attention. When we calibrate the model with these distributions, what we find is a very low correlation between virality and quality. And to illustrate that, here I'm plotting the distribution of popularity for two sets of things being shared. Very low quality and very high quality. And what this shows you is that the two distributions are undistinguishable. These are these two curves at the top. And for reference, the inset, that's data from Facebook. I mentioned it earlier, from emergent.info. And it's very similar. Again, these are links to reliable news versus links to fake news, and the distribution of popularity is indistinguishable. Okay? So this is a little bit depressing here, I'm sorry. But it suggests that even if people are able to tell good stuff from bad stuff, just being overwhelmed means that a lot of bad stuff is going to go viral. It's kind of inevitable. But this is actually an ideal situation where people, are able to recognize things, and furthermore, the platform is not really biased in what they present. In that model, things are presented in chronological order. However, when we go and measure how different platforms expose people to different sources of information, we find significant amounts of bias. So these plots here show you two kinds of bias. One is what we call popularity bias, and one is we call homogeneity bias. Homogeneity bias is the tendency of a platform to show predominantly links from a small subset of all the set of all the sources. And this is done measuring entropy, which is a way to measure this kind of diversity. And the popularity bias shows the tendency of websites to show content from the websites that have the highest page rank. And of course, what is the baseline, right? I mean, we do expect things that are more important and more popular to be shown and visited more. So we had to have a meaningful baseline. The baseline here is a random walk through the network, which is itself a very biased process, because we know that a random walk on a network that has the structure of our information networks predominantly sends people to the most central pages, the ones that have highest page rank. But it turns out that even if you use that as a baseline, pretty much all of the platforms for which we were able to analyze data, this is data about traffic, how people click, have a greater homogeneity and popularity bias than even this very skewed baseline. So what this suggests is that, well, of course, as we suspect and as we know, platforms use algorithms to try and surface the stuff that we're more likely to be interested in. And very often those are the things that are popular. Those are the things that are engaging. Those are the things from the sources that we like. So we're shown the same sources again. But in so doing, the platforms are introducing significant bias. And let's focus for a moment on the popularity bias. What is the effect of the fact that a platform is more likely to show you results from something that other people are also looking at? And this is, by the way, something that all platforms do, right? This is called engagement. This is the bread and butter of platforms. They make money by showing you things that statistical models predict you're going to click on, because that way you remain engaged in the platform and you're likely to click on some ads. And that's how they make money, and how we all who are shareholders through our retirement accounts also make money. So let's be clear about that. So we all like it, right? And so what is the effect on quality? So to explore that, we built a very simple model where in this model, we could kind of tune how much a system might rely on popularity versus just on the quality. So again, we assume that things have some quality, and then when you're shown something, it could be selected with a probability that depends on just the quality versus with a probability that depends on how many other people have also seen it or clicked on it, okay? And in this model, there is another important component. It's very related to the attention parameter that I showed you before. Like, how likely are you to go down and see more things, right? If you see more things, then the ranking is not that important because you're going to see things even that are not top ranked. But if you only see very, very few things, then the ranking algorithm has a very big impact on what you see, right? So as the popularity bias increases, in general, the quality of the things that are shared decreases. Now, there is a narrow situation, a narrow range of values for this exploration cost or attention parameter, in which actually ranking by popularity helps. Because what it does is that by leveraging what other people are seeing, the platform can quickly determine what is good. Because people, when they are exposed to things, they will tend to select things that are good. So the platform can say, well, all of these people are clicking on this, so I'm going to show this to you. That's good, right? That's actually the whole point of why platforms use engagement and popularity. Because the idea is that they can use signals from what people are doing to estimate the quality of a piece of information. And that can work, but in very narrow situation, okay? In general, unless you are in that very narrow range of parameters, in general, selecting by popularity will simply add noise. It will amplify initial fluctuations. And so in the end, overall, people are going to be exposed to lower quality. That's what these plots show. So algorithmic bias could, in theory, help, but we don't really know whether it does, and we know that it can easily harm. Another source of bias, or another factor that can make us vulnerable, is the structure of the network. I mentioned earlier that the structure of the network is important in terms of clustering coefficient and hubs and so on. But one thing that we didn't reproduce in the models that I showed you until now is the community structure of the network. Well, the network has a very strong community structure. Many people, in addition to our group, have shown this. And if you look at who's retweeting whom, you'll find these very dense, polarized, segregated communities. This is, for example, people who were talking about politics a few years ago. The liberals only retweet other liberals. The conservatives only retweet other conservatives. Some people refer this as to echo chambers. Other people have sort of a different definition of echo chambers, so I have to be careful about how I refer to this. But when I talk about echo chambers, I simply mean this: the fact that people are more likely exposed to information from other people who are similar to them. In fact, this kind of structure is so strong that you can just look at a person's friends and guess whether they're liberal or conservative with a very high accuracy. And the structure of these echo chambers is interesting. They have well, we do something called K-core decomposition, which sort of strips the more peripheral nodes iteratively and to look at the core. And the core is the set of accounts that are very, very tightly and densely connected to each other. And these networks have very deep core. Okay, so what that means is that there are many, many accounts who follow or retweet many other accounts in that core. So that information spreads very, very fast inside those cores. They are basically like a large number of accounts that are highly coordinated and synchronized. One person shares something, 1,000 people share the same thing immediately. So the structure of these networks almost seems designed for the fast spread of stuff. So one question that we have, and this is a tough question to answer, but what is the role of online social networks and social media in fostering these kind of echo chambers, the emergence of this polarized, segregated structure? So again, it's hard to evaluate this with empirical data, very, very hard, because we don't have a parallel universe in which Facebook and Twitter don't exist. And so, of course, we also know that homophily exists irrespective of technology. You still are going to have friends who are similar to you, right? So how do we evaluate this? So we built a model, again, similar to the ones I described before, simulating a system where people are sharing things. And the things that they share are a reflection of their beliefs. So now we have this new ingredient, the belief. Each person has a belief, which is very, very simply represented as a number in a range from progressive to conservative. And there are two important ingredients here. One is that when you see something shared by a friend, you can be influenced by it a little bit. Okay, there is a parameter that says how much you can be influenced. And as long as that is non-zero, it doesn't really matter how big the parameter is. Okay, so it's some epsilon that says you can be affected even a little bit. Okay, so if a lot of people are sharing conservative things, eventually you might revise your thoughts, become a little bit more conservative, and vice versa. So this is the first ingredient, social influence. The second ingredient is unfriending. That is, if you see somebody posting something that you really, really don't like, there is a small chance that you will unfollow them or unfriend them. Again, it doesn't matter how big this chance is. This is a parameter. It can be as small as you want as long as it's not zero. Okay? So there is epsilon 1 and epsilon 2. So what happens in this world? People are sharing things. You can see their beliefs. You can see how their beliefs change over time. Of course, this is a highly accelerated simulation. And you could see how people unfriend their friends. Those dashed lines are people who are unfriending people and replacing those friends with new randomly chosen people. Okay, so basically you have random resorting, but you have selective unfollowing, and you have a little bit of influence. And you let it run. And you can run this as many times as you want. The outcome is always the same. Always the same. This is the outcome. It's inescapable. It's inevitable. Actually, it's not even that surprising because this model is incorporating other models that have been well known for many years. Okay? So we just sort ourselves out. And it's inevitable. We end up with this. And if you wait long enough, the two communities will completely disconnect. So I'll let it run while I get a sip of coffee.
Is that a red guy converting? He's switching over?
Sorry, I didn't hear that?
Is that a red guy like converting? Who's switching over?
Yeah, people are constantly seeing the things posted by their friends, and they may change their opinion a little bit based on that. But generally, when you see a highlighted node, that just means a node who's unfollowing someone else. When you have these two completely homogeneous and segregated communities, there is no unfriending anymore because you no longer see anybody that you disagree with. Now everybody, it's wonderful. We're happy. We're surrounded by intelligent people just like us who have figured it out And you wonder, how could there be people who don't understand and see things the way we do? Okay, so the point here is that the platforms are not trying to do anything evil here, right? They're building a system that we like. They're allowing us to follow whoever we want. They're just making it really easy for us to do what we want, to see what we like, to read what we're interested in. But it is kind of easy to overlook that simple choices, algorithmic choices like that, may have inescapable consequences that we may not like. Because the output of this is that people are not exposed to a diversity of ideas. So of course platforms are not this naive, right? Obviously they make recommendations that are not quite that naive, but at least this is, I think, kind of a wake-up call that suggests that we have to think carefully about what are the consequences of algorithms that make recommendations to us as to what we might be interested in or what people we might know. And when we add this kind of segregated structure in our model, and we look at how misinformation and debunking compete with each other, it turns out that, this is yet another model, without going into much detail, it turns out that other things being equal, the more segregated a network is, the more likely it is that a piece of misinformation will continue to prevail and to remain viral for a long time. Simply because one community is simply not exposed to the debunking. In this model, we assume that if you're sharing some fake news and then you see somebody who says, hey, that's fake, you will stop sharing it. But the more segregated the network, the less likely that is to happen. And in fact, we tried to do this analysis for our own network, remember? The stuff about us being a secret federal agency spying on citizens to suppress conservative speech. This is a network of retweets of people sharing those fake news. And we try to look at where was this situated in the Twitter sphere. And so we put this in a larger network of people who were talking about the elections at that period in time. And this is the picture. The purple nodes are the people who were sharing the fake news about our project. The orange nodes are the ones who were sharing the debunking from science and Columbia journalism, etc. Do you see the debunking there? There are a couple of nodes here. That's it. Okay? Whereas, look here, how many people are sharing the fake stuff. And many of those were sending angry tweets at us, asking that we be fired and so on and so forth. So that's sort of, that's the point here, right? You can debunk all you want, but if nobody sees your debunking, it cannot possibly be effective. Now, who knows? Maybe even if people do see your debunking, it may still not work. There is still a lot of sort of different results that point to different situations in which fact-checking and debunking may or may not be effective. But my point here is that all of that debate that is going on is kind of irrelevant if we imagine that the debunking is not even reaching the people that it's supposed to reach. All right, so I'm out of time, so let me summarize a few points here that I try to make. First is that we are exposed to and we spread misinformation through an interplay of cognitive, social, and algorithmic biases. Social network structure, limited attention, information overload, these are factors that make us vulnerable to misinformation. Good news is that network, temporal, content, and user features can be used to detect some kinds of abuse, like AstroTurf, social bots, and coordinated campaigns as well. But bots are getting smarter, and they are effective at spreading misinformation. That we know. We think that it is important to do research and to work together, researchers, journalists, platforms, to build tools to detect manipulation of public opinion, and these may first steps towards a more trustworthy web. And there are many, many interesting directions here. But we also need to build tools to aid fact-checkers and to teach news literacy. That is something that I have not talked about at all. But let me just point out one slide. I mentioned earlier Mihai, my student sitting there. This is a project that he's working on. And the idea here is to build a game that will help people become more aware of how easily they may fall for misinformation. So it'll be something just like your Facebook or Twitter feed, and you will see news that look just like they're coming from your news feed. And sometimes you see them, and I would have a very hard time telling if this is fake news or real, if I did not know, right? I would click false. I would click fake, but okay. So the point is that perhaps we have to explore everything, and perhaps even games can be one of the many sort of tools in our arsenal to try and help make people at least aware of how easily they can be vulnerable. We all can be vulnerable to manipulation. And let me close by thanking all the great students, postdocs, and colleagues in our lab. This is their work. And also, if I can have a shameless plug, we are looking for a postdoc to work on these research questions, so please help us spread the word. And we're also always looking for good PhD students. We have several positions available. Okay, so with that, I'll stop, and maybe there is some time for questions. Thank you.
First of all, thank you for this amazing work. You know, this is such a it blows my mind, honestly. I just wonder, you touched a little bit on Facebook. I mean, most of your research is, as I understood, is based on Twitter.
Right.
We know. So how do we go about Facebook? Thinking about how do we do research like this on Facebook?
It's a challenge. Well, we have some of our friends and colleagues and former students who work at various platforms, and so we try at every chance at a conference like this or meetings to talk with them. And I'm optimistic. I know that they are concerned. I'm not among those who thinks that platforms are evil. I think that they have good people who are concerned about stuff. Of course, they have strong constraints and financial ones. But nevertheless, they are trying to build useful tools. And so they are sometimes slow to recognize problems and naivetes, but I think that they're catching up fast. And my hope is that by engaging with them, we can work together. We have to do research together. We have to find a way for platforms to share data with researchers. This is very, very hard. They have good reason not to want to do that, okay? First of all, it's private data. And so it's also our data. One day we're very upset that companies get hacked, and the next day we're very upset that Facebook doesn't share data. Well, so we have to realize that there are good reasons. Of course, privacy is just one of them. There is secret sauce types of arguments. There is the very good point that by sharing countermeasures, then that will make it easier for attackers and abusers to manipulate results. So we have to find mechanisms that allow researchers and platforms to work together, and for platforms to leverage the talent that exists outside of their organizations, no matter how many smart people they have, and they have lots of smart people, but still there's a lot of more talent out there. And my hope is that we can find some mechanism to work together. There are ways to do it. You could imagine agreements where researchers can access to data under very controlled situations. Right now it already happens. Platforms often invite certain researchers to work with them, for example, through students or internships and sabbaticals and so on. But it is not done in a systematic way. So it's very unequal. Some people have more access, some researchers have more access than others. We need to find a way for maybe through a consortium or some intermediary that gives to platforms the guarantees that they need, that the data is not going to be abused, and also gives researchers a way to study what is happening and to understand whether countermeasures are working or not. So I think that it is absolutely necessary to collaborate. Facebook is doing really well in certain ways. They are trying a lot of things. They're investing a lot in literacy. They are working with fact checkers. They're doing a lot of things. Twitter is better from my perspective as a researcher in some sense because their data is more easily available, and I really, really appreciate that. On the other hand, it's a smaller company. They don't have the same resources. So we don't really know what they're doing. Maybe they're doing a lot, but we kind of not know about it. Google is another one that we should also mention. We know that they're doing great stuff. Some of the people are here, in fact, from Google News who are implementing tools to help surface fact-checking information. And I think that a lot more can be done. And my hope is that we can work together for that.
As a tool to aid fact checkers, have you considered building amplification tools? Or is that kind of against the rules in some way?
It depends on what you mean by amplification tools. I am all in favor of amplification tools that are not deceptive, right? So I don't think that it would be ethical to build bots that make it that deceive, even if it's for good reason. There is some research now going on, and researchers building bots to study how they can be impactful, and they can be impactful. But I think there are important ethical questions there. So I'm all in favor of building tools that aid fact checkers in spreading their word and making sure that the stuff is seen by the people who should see it. But I would feel really bad about using some of the techniques that the abusers are using. I don't think we should do that.
I just wanted to ask how you defined quality and how you measured that.
Thank you. I probably wasn't very clear there. In the second part of the talk, where I was talking about our models, where we look at the correlation between quality and virality, these are theoretical models. These are toy models, where we can do whatever we want. And so we basically just define quality as a number between 0 and 1, and drawn from some distribution. And this may not be very realistic. It's one of the assumptions that we make in our model. But it allows then to tease out the correlations between the virality of a piece of information and its quality. I think that the answer to your question is I have no clue. It is very, very difficult programmatically with machine learning tools to look at a piece of text and to say whether it is high quality or low quality. We're nowhere near the technology where we could use artificial intelligence to do fact-checking. Absolutely. So now, that doesn't mean that we can't leverage signals that could aid fact-checkers. Certainly, if something is coming from a source that has been repeatedly debunked, or is it shared by accounts that are clearly automated, that will give us signals, and we can build machine learning systems to use those signals to help fact checkers. But that's very different from looking at content and be able to say if something is true or false. So we certainly can't do it, and because we're not journalists and fact checkers, we're not in the business of making that determination. So in our models, that is completely sort of a theoretical quantity.
So I'd agree with the others. It was a really interesting analysis, but sort of really depressing as well in some ways.
Sorry.
And I guess if the system has these inherent properties, then is the solution, if we're not going to be as deceptive ourselves, one of regulation or some sort of set of protocols on the platforms for dealing with these sort of sites?
That's a really, really good question. I actually get asked that quite a bit, and I am neither a policymaker, nor a journalist, nor a lawyer. So I really do not feel qualified to comment on that debate, but I'm happy that that debate is happening. I'm happy that we're talking about the advantages and disadvantages of self-regulation by platforms versus some kind of regulation, which could come from governments, or it could come from independent organizations that companies engage with, which could help sort of have some kind of seal of approval or something like that. I believe that the natural tendency of platforms is to try to avoid regulation. And I think that in the US, it's very unlikely that we will have regulation anytime soon because of the strong emphasis on freedom of speech. That might be different in some other countries, and it's possible that those countries might drive some of these efforts, because of course it is not feasible sometimes for platforms to have different systems that work in different countries. So if they're forced to develop techniques that comply with regulations in one country, they might as well implement it in the others. But I'm not advocating that. I really do not know. I think that there are very strong pros and cons, anything that you try. It's not a simple problem. I don't think that you can just simply regulate it. There is a very slippery slope between quality assessment and censorship. And we have to be really, really aware that it's not a trivial problem, and that debate will probably continue.
We have time for one more, I think.
I'm Yusuf. I teach journalism at the University of Oklahoma. It was interesting when you said that there are like only a few people who are debunking misinformation, when like a lot of misinformation are coming to us like through social media. And that's exactly what I was telling my students and my colleague who I work with. So I believe that there must be a social network to fight misinformation like in other networks. So do you think there's a possibility that we can have a social network that will have like journalists, that will have the people who possess all the information, the facts, who can really verify the information, who have the information, and also the users who really care about good information and who are worried about misinformation? Thank you.
It is not simple to say we can have people who care about good quality information. I can assure you there are a lot of people who really, really care about good quality information, and they think that they can only get it from Breitbart or from some other source. So I think that we can't simply say, you know, these are good, this is trustworthy, these are not. It's a hard problem. You can have a social network of people who work together, and then you'll have another one that will work together for something else, and they will accuse each other of being biased. So, but this is not to disparage the idea of working together. I completely agree with you that we need to work together, and I believe that one of our goals in research should be to build tools that allow different parties to work together. We have right now so many people who are working on fact-checking, technology, new startups, existing media companies that are investing in new tools, foundations who are investing in building tools to aid fact-checkers. We think that a lot of good can come from that, and I personally think that one of the directions should be to make it easier for them to work together. So we have different fact-checkers. They don't always talk to each other. And it's possible that when one fact-checker is doing some research, they might profit from research that has already been done by somebody else. So how do we make information about past debunks readily available in an easy machine-readable format, or for algorithms to reason about it across the spectrum? And we need to build that. We need semantic web technology, we need machine learning, we need standards so that it will be easy for information to be shared. Maybe nobody has fact-checked this particular fact, but this fact involves these entities. And here's all these other things that have been debunked about these entities. Or maybe this claim was made by this source, and here's all these other debunks that have been made about that about articles from that source. So I think there is a lot of improvement for computer science, a lot of opportunities for computer science research to improve on our capability to work together.
Great. Thank you very much.